Okay, this is review 3.2 for math models. This is all about radicals, square roots, how to reduce them, how to use them to solve for x and things along those lines. The first thing we need to remember is to reduce radicals, we need our perfect square. So like 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, there's no decimal right there. 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121, 12 times 12 is 144, 13 times 13 is the dirty one. 14 times 14 is the kinky one, and 15 times 15 is 225. Alright, those are your perfect squares. That's what you're going to be using to divide with. So for your radicals, you want to divide the largest perfect square that you can. So for this instance, 27 is divisible by 9. 9 is a perfect square. Yes, it's also divisible by 3, but the 9 is what we want to zero in on. It is 9 times, that's a 9, believe it or not, times 3. Alright, we can reduce that 9, take the square root of 9, it becomes a 3. So the answer is 3 on the square root of 3. Alright. Number 2 is the same way. Now, lots of things go into 48. 6 goes into 48, but 6 is not a perfect square. What we want to use is there's also 4. 4 goes into 48, and 4 is a perfect square. But you'll see if I use 4, you're going to have to do this twice. So I'll show you with the 4 real quick. 4 times 48 is 4 is times 12 is 48. Alright, so if I pull that 4 out, it becomes a 2. But 12 has another 4 in it, so that's 2 on the square root of 4 times 3. And when I pull the 4 out, again, square root of 4 is 2. And then multiply the 2 2's out front, that's 4 on the square root of 3. That's your answer. Now, the reason I had to do it twice is because, yes, 4 is a perfect square up here, but it is not the biggest perfect square. I could have instead used 16. Alright, 16 is a perfect square, 16 goes into 48. The square root of 16 is 4, so that's 4 on the square root of 3. So in one shot, we got our answer. Alright, so basically here's how I look at this. I start at the highest number that I can. So in this instance, I would not try 100 or 121. Those are way too big. But start with the biggest number you can and work your way down. Alright, the biggest reasonable number there is. That way you may start with the 25, find out that doesn't work, then move to the 16, and find out, oh, that works. That way you can get it in the first shot. So here we go. I'm going to burn through the rest of these real quick. 75. The biggest thing that multiplies into 75 is 25. So 25 times 3 is 75. And the square root of 25 is 5. Alright, so at this point I would encourage you to pause the video, work through 4, 5, and 6, see how you can do, and then come back. But I'm going to keep on moving. Alright, 128. 128 is divisible by 64. That's 64 times 2. The square root of 64 is 8, so 8 on the square root of 2. $245. Now I don't know this one off the top of my head. This is the one that I would start. I'd probably start with 144. 244 is not divisible by 245 is not. So I start with like 2. Oops. I start with 245, and I would just start dividing. Divide it by 121. That doesn't work. Divide it by 100. That doesn't work. Divide it by 81. That doesn't work. Divide it by 64. That doesn't work. Divided by 49 and go, oh, 245 is the square root of 49 times 5. And the square root of 49 is 7, so 7 on the square root of 5. So yeah, every so often you're going to have to just work your way through it. And again, start big and go low until you find it. Alright? Last but not least, 726. We're going to go through the exact same process. So I'm going to start with 726. And since we can start big, I'll start with 225. Since 225 ends in 5, I know it's not going to go into 6, so I know that's not going to work. 726 divided by 196, that doesn't work. 726 divided by 169, no. 726 divided by 144, no. Divided by 121, and yay, it works. 726 is 121 times 6. And the square root of 121 is 11. So 11 on the square root of 6. Alright? And there you are.